Okay, hello everybody. My name is Adam Semensky. It is my great pleasure to welcome you here in my capacity as the president of KAPSARC. I'm delighted to see so many people joining us today to explore aspects of the circular carbon economy, or CCE, concept. KAPSARC engaged with leading international organizations to write a series of reports on carbon management that form the basis of the CCE guide. The cornerstone of the guide collaboration has been that each partner has full independent control over the content of their reports. The CCE webinar series will explore the key results of those studies. I would like to offer a very warm welcome to today's guest, Michel Barthelemy of the Nuclear Energy Agency at the OECD in Paris. He will be discussing the role of nuclear power in the circular carbon economy. First, let me say a little bit about KAPSARC. We are an independent nonprofit research think tank located in Saudi Arabia. Our mission is to advance the understanding of energy, economics, and the environment, and act as a catalyst for dialogue on issues of importance to policymakers and the public. This year, the respected University of Pennsylvania think tank survey ranked KAPSARC in the top quartile of think tanks globally. The Saudi G20 presidency selected KAPSARC to co-lead the think tank engagement group called the Think 20 or T20. Our Vice President for Research, Dr. Fahad Al-Turki, was appointed to chair the T20. On a separate track, our work on the CCE guide was used extensively by the G20 energy ministers, and the CCE framework was adopted and endorsed at their September meeting. Now, let me just briefly explain the circular carbon economy. And of course, Eric and Michelle will do more. Experts largely agree that the challenge of achieving our climate goals is best met by encouraging all options to manage GHG emissions. One of the organizing principles of what we call the circular economy is the 3 R's of reduce, reuse, and recycle. The circular carbon economy embraces each of these 3 principles and adds a 4th, for remove. The 4 R's represent the basis for carbon management in the circular carbon economy. Reduce the fugitive carbon, recycle and reuse carbon as a valuable resource, and remove excess carbon and store it. The CCE framework is an integrated and holistic approach to a more comprehensive, resilient, and climate-friendly energy systems that support and enable sustainable development. CCE encourages the broad use of technologies associated with managing carbon dioxide and other GHG emissions, and seeks practical solutions to foster economic well-being and improvements in the quality of life for everyone. Now let me introduce Eric Williams. Eric is a senior research fellow at KAPSARC. He has over 20 years of experience as an energy and environmental economist, focusing on energy and climate change policy, energy systems analysis, and climate change mitigation and adaptation options. Before joining KAPSARC in 2018, Eric worked as a utility commission economist, was a consultant at the OECD, and Eric has previously worked at the United Nations, the academic research institutes, think tanks, and in government. Eric, over to you, please.
Thank you, Adam, for a very kind introduction. So I am just going to talk very briefly today to give you a little bit more of an overview of circular carbon economy. So I'll first start by just looking at the differences between circular economy, which many of us are familiar with, and circular carbon economy. So as Adam mentioned, circular economy uses the principles of reduce, reuse, and recycle. And circular carbon economy takes those core principles and adds a 4th R for remove. And I'll go through in a little bit more detail just after this slide what those really mean in practice. So circular economy is a framework for sustainable production and consumption. The circular carbon economy is really a framework for climate mitigation that values all options. The circular economy scope is really focused on resource and material flows, while the circular carbon economy scope is energy and carbon flows. The goal in the circular economy is to minimize resource consumption and waste disposal. The goal in circular carbon economy, on the other hand, is to manage greenhouse gas emissions, including CO2, toward a balance or a net zero. So how does nuclear fit into the circular carbon economy? If we look at the left, this is a very stylized representation of a linear carbon economy in which you have hydrocarbons that drive economic activity, and then CO2 emissions result. So in the circular carbon economy, we can apply the principle of reduce, which reduces the CO2 that is generated in the first place. And nuclear is one of those options, along with renewables and energy efficiency. You can see on the right, as we move toward a circular economy of material flows in the middle, we can add in energy efficiency, nuclear and renewables, and that reduces the CO2 that is emitted or produced. And then if we step back to look at the bigger picture of the circular carbon economy, we still have the circular economy in the middle, energy efficiency and nuclear and renewables that reduce the CO2 that is created in the first place. But we can also recycle CO2 through bioenergy, through the process of photosynthesis and natural sinks. We can reuse CO2 that feeds back into the circular economy. We can also capture CO2 from the air through direct air capture and through point sources and store it geologically. And so that is a very, very brief overview of the circular carbon economy. I would invite everyone to visit our website, cceguide.org, to learn more. Thank you. And over to Michelle.
Everyone, and thank you, Eric, and thank you, Adam, for the introduction. Let me start by saying that it has been a great pleasure and an honor to work to support the work of the G20 presidency by Saudi Arabia and to explore with our fellow international organizations the concept of circular carbon economy. Today I'd like to discuss more specifically the role that nuclear can play in this framework. But before that, recognize the fact that indeed, addressing climate change is an incredibly challenging and complex endeavor, and having framework, intellectual frameworks such as those developed by KAPSARC on the circular economy, carbon economy, so that policymakers can understand and address this issue is incredibly useful, and I'm sure that this will be very fruitful in the years to come. So what we've done in this report is to explore the big picture for the role of the nuclear power, and I start with an outlook that our sister organization, the IEA, has developed for in particular in the sustainable development scenarios. They've looked at the role that nuclear play toward the 2-degree scenarios, and what you can see on this chart is first the current nuclear fleet with different hypotheses regarding its lifetime extension, and you can then see a planned nuclear new build, and last but not least, you have the green curve, which shows you the role of nuclear power in order to be on track with respect to our climate objectives. And from this chart, there are a couple of important messages. The first is that unfortunately, nuclear is not on track. And even in a scenario where we will extend the world nuclear fleet to 60 years or more, this won't be enough. And this won't be enough, and the gap will only be partly met by planned nuclear construction. So there is an important need in the short term to foster and accelerate nuclear new build plans if we want to meet our climate objectives, and that include both large Gen 3 nuclear reactors and small modular reactors that are under consideration in a number of countries. If I now move to another view about the perspective, particular looking at what the IPCC scenario says about growing world, this time toward 2050, in the scenarios compatible with a 1.5 objectives. You can see that this world is growing even more. And on the right-hand side of this figure, you can see that by 2050, we are talking about potential CO2 emissions avoided by more than 3 gigatonnes of CO2 per year. So this is quite significant, and that's about 10% of the CO2 emissions of the energy sectors in 2018, which is the latest year for which we have up-to-date data. But you can also see, and it's important to recognize the range of that nuclear power takes in these different scenarios. And indeed, they do consider that nuclear power won't grow or would be even reduced. And then that very much brings to question as to whether these scenarios are compatible with the circular carbon economy. And in particular, when we look at the very significant growth required consequently for renewables, as to whether these scenarios are robust in terms of the means to integrate very large share of renewables. And this is work that we've done at the NEA over the years, in particular on what we call system costs. And what we see is that there is a number of challenges regarding integration of very high share of renewables that are not necessarily going to be captured by these sort of energy-wild decarbonization scenarios. And so in that sense, there can be concern regarding the significance and the robustness of scenarios that will push nuclear to a higher level, renewables to higher level, and reduce nuclear. And this links to another issue, which is that in a number of scenarios where you see that both nuclear power and renewables come and play together to support decarbonization objectives, you can see that often nuclear complements renewables very well. And this is in part because nuclear is not only able to produce baseload electricity, but it is also able to provide a number of flexibility services that will help to manage renewable intermittency. Now, in addition to this value of nuclear power for managing and supporting renewable integration, and a core focus and message in our report is that there are a number that can really play a very effective and strong role to support the decarbonization of energy sectors more generally. I'm highlighting here 3 on this figure. First, you have district heating applications, and it's sometimes not well known, but the number of countries that have been using district heating for a number of years is, you have an example with the Besno nuclear power plant in Switzerland, but in former Soviet Union countries, it has been widely used for decades now. And essentially, considering that nuclear power plant first and foremost produce heat, it's indeed not surprising that they can be very well suited for these applications. Secondly, and this is of course more of interest for the Middle East region, is desalination. Here, one of the key attributes of nuclear power plants is that they can operate with a high load factor, and so they can be very efficient for desalinating very large-scale quantities of water. And I don't need to tell you that this is one of the sector of the economy where energy needs are growing at the fastest rate in the world these days. So clearly it is an area where there is a very high demand, and where all low carbon technologies have a role to play. And then last but not least, there is a broad category that I put here as process heat that range from petrochemical applications, biorefineries, and last but not least, hydrogen production. And there again, it is an area where we have historical examples, but we also have concrete case studies recently, and I think maybe it's worthwhile to stop on hydrogen for a couple of minutes. It is widely discussed these days, and we can come across terms such as green and blue hydrogen, but the bottom line is that what you want is low carbon hydrogen productions. And if you're thinking about using electrolysis being a low temperature or high temperature, you can see that doing it through the grid and doing it with nuclear power, to the grid, if you have a low carbon mix, and with nuclear power more specifically, can be a very efficient and economical way of producing hydrogen. So all of this to say that these non-electric applications can have a very significant potential. The barriers are not really technology, because this is things we have been doing for a number of years, but they are more in terms of fostering licensing and demonstration for the coupling, in particular between an industrial plant, for instance, and requiring industrial heat and a nuclear power plant. And there are also more generally about policy support for such demonstration plants. But maybe one more point here, which I should have started with, is that if you remember the IPCC scenarios I've showed you before, or also the IEA scenarios, in fact, most of them don't really look at this non-electric application. So it is a significant potential, but which is not counted when we look today at the potential for nuclear power in the circular carbon economy. So next slide. So all of this brings me to a number of policy recommendations for nuclear power to play its full role in a future low carbon future low carbon energy mixes. Here we have summarized them into 4 categories, which will help to address both the traditional role of nuclear as producing base load and flexible electricity, and these other non-electric applications that I have just mentioned. So first, you're going to have a number of issues related to electricity markets. We see in particular in OECD countries where electricity markets have been liberalized for a number of years, that they are not right now in a state of play that can provide the long-term price signals required for fostering the low carbon investments we need to meet our decarbonization objectives. So there's a number of issues at stake here that are going to be needed, for which policy action is going to be needed. And in fact, this is an area which is not very specific to nuclear power. And in fact, these policy reforms will support all low carbon technologies, be it nuclear, CCS, or renewables. Second, when we look at nuclear, in particular nuclear new build for countries having near-term plans, we see that the key bottleneck right now for final investment decisions is with respect to financing. And we see in many conversations with government that there is increasing awareness that they can do more to support these financing equations. And so there's a number of direct and indirect financial support that can really play a significant role to support near-term projects. This is also an issue for international financial institutions with respect to clarity for the lending policies, and that is especially important for emerging economies. Third is innovation and investment in nuclear R&D, and in this field in particular, I briefly mentioned the important role and prospect that many see for small modular reactors. As many of you will know, Saudi Arabia has a program for the development of small modular reactors. And so across the world, we see countries moving in this field. But this is a field where we still need a demonstration project so that we can have more visibility with respect to the performance, the economics of the technology. And these demonstration projects are in terms of billions of dollars of investment. So there again, government have an important role to play, and this will also be applicable to these non-electric applications that I have mentioned. And then last but not least, last area, which in this case is maybe more specific to nuclear power and less applicable to other low carbon technologies, is international licensing framework. And that's especially important because if we think about these innovative nuclear technologies such as SMR, they will require tomorrow a global market. That will be a key factor to improve the competitiveness, because that means you can standardize the technology more, you can build in series and derive cost reduction from that. And right now, in the nuclear safety regulations tend to be essentially developed at the national level. So you need to find ways to develop some licensing approaches where countries that want to come together can find ways to do so, and where you can find convergence on a number of areas. So this is very much stepwise, but it is incredibly important for the future competitiveness of nuclear technologies such as small modular reactors. So this brings me to the last slide, which for which I have summarized some of the key policy recommendations that we formulated for the G20. And we have organized them into two categories. There were a number of generic policy issues that are essentially pertaining to existing and new nuclear power plants that can produce either electricity or heat. And there are a number of issues which are specific to nuclear applications. So if I start with the G20 action for new build and existing renewable fleets, one of the key things that has become clearer as we developed this report over the last year is one of the big things that hit us was COVID, and we've seen a number of countries developing recovery plans, and we see that as advanced and emerging countries are thinking about post-COVID recovery, more and more the issue of strategic infrastructures is getting more focus, more attention by policymakers. And in that respect, there is a clear opportunity to support nuclear power in post-COVID recovery. Second, and in particular, and haven't had time to go do that in a lot of detail, but when we look at near-term nuclear new build project, they have a very strong window of opportunity to learn lessons from recent first-of-a-kind projects, and that can play a very significant role to support rapid cost reduction. And so for countries that are considering nuclear power, there is really a window of opportunity for them to support nuclear power and by doing so to reduce cost, as they have supported renewable over the last decade and has had a very significant impact for reducing the cost of these technologies. Then I mentioned three issues that I've already discussed in passing, so electricity market reforms, the support to small modular reactors, and last but not least, the inclusion of nuclear energy in future sustainable funds, considering that nuclear is low carbon and has very benign life cycle environmental. And then the second part of the policy recommendation, which I will finish with, is the non-electric nuclear applications. They are really, and I think I hope have illustrated that enough, very promising nuclear cogeneration opportunities, and support to demonstration plan in this area can really have a very impactful results for our ability to manage CO2 emissions, and in particular producing hydrogen with nuclear power is a very promising avenue, and in that respect it should be considered on an equal footing with respect to other low carbon technologies. And maybe finishing with where we started with these long-term decarbonization scenarios. As I mentioned, when you have a deep review of these scenarios, you see that they often don't consider non-electric application. And so really, if you're serious about considering all our options for meeting our climate goals, we should really develop such scenarios, including this non-electric potential of nuclear power. And I'm certain that the circular carbon economy framework and guide can help policymakers and practitioners to move forward in this area. So with this, I will stop the presentation and be happy to take any questions.
Thank you very much, Michel. We have had a couple of questions come in, and let me just say what those are, and Eric and I might have comments too. One question had to do with the waste disposal issue associated with nuclear. What's the latest on finding ways to plan for the disposal of used radioactive materials?
So, important part of the debate has been with respect to the feasibility of a deep geological repository, and on this we've actually produced a report a few months ago that identifies that there is very strong international scientific consensus regarding the feasibility of such solutions. My first answer is at the scientific level, there is no doubt about the fact that these are sustainable and feasible solutions for the long-term management of high-level radioactive waste. In a more practical manners, and then we see that a number of countries are actually making progress. We see in Europe, in particular, countries such as Finland and Sweden that are moving forward. I think the waste repository in Finland will be operational in next year or so. And similarly, in a country such as France, they have had a laboratory that explores the sort of long-term geological behaviors of such repository for a number of years, and France is also moving forward in this area.
Thank you. There were a couple of questions that basically had this as a theme, that nuclear power may not be producing CO2 during its operations, but hydrocarbons are needed in mining and processing of uranium, and therefore it's maybe not fair, the person might say, to think of nuclear as a carbon-free alternative. Michel, I'd like to hear your thoughts on that, but let me just add that in my view, a full life cycle analysis of all of the options associated with managing carbon and all of the fuels is probably a good idea. Just for example, waste disposal for solar panels is likely to be a serious issue. The solar panels contain a lot of heavy metals, and these are either going to have to be recycled or disposed of properly in some way. And wind turbines use a huge amount of concrete to anchor the turbines, and cement is a large emitter of CO2, and the turbine blades are made from hydrocarbon products, fiberglass. So I think it's probably worth saying that no fuel is perfect. All fuels have issues, and we need the scientists and engineers to think about this from a full life cycle analysis basis, and then and let the engineers get on with managing these things. Michel, I don't know if you want to make a further comment.
Well, you basically answered the question, Adam, but indeed, the way to go is to take a full life cycle analysis approach, and a very structured sort of methodology to do that. I think they even have ISO certification, classification, and if you do it for nuclear power, I think the consensus from IPCC is a median is CO2 is 12 grams per kilowatt of CO2 per megawatt hour. Countries such as France that already have a very low carbon mix is at only 6%, 6 grams. So yes, nuclear has CO2 emissions over a life cycle, but this when you divide that by the electricity it produces over its lifetime, this is very, very low. Maybe to go more detail into the life cycle impact, there are two main categories. So there are three. There is the CO2 emissions you need at the front end when you extract uranium in minings and so on. And indeed, usually need petrol to drive your lorries and so on. But considering the energy density of uranium, you actually need very few tons of uranium to run nuclear power plants per year. So this is very, very, very low. Then you're gonna need quite a bit of energy to enrich your nuclear fuel. And for that, we've actually been transitioning, the nuclear sector transitioning from one enrichment technology towards a new one that is far more efficient. So it has had quite a big impact on these CO2 emissions. But in addition to that, if you're in a country which has a very low energy mix, such as France, electricity mix, I should say, then the impact is even stronger. And then you're going to have emissions during the construction, in the concrete and so on, direct emissions. But again, these are, given the lifetime of nuclear power plants, these are very low, have very limited impact on the carbon footprint over the life cycle.
I just want to be clear on another thing too, Michelle, that the Circular Carbon Economy Guide is trying very hard to be technology and fuel neutral. Renewables are absolutely critical, I think, to managing carbon emissions, as is efficiency. And renewables and efficiency are very well studied and presented in the Circular Carbon Economy Guide. Do you see compatibility between nuclear and renewables? I mean, are they competitors or can they be complementary?
No, and I started mentioning that in passing during my presentation, but our view at NEA is that you should very much consider nuclear and renewables as complementary. I think there is three levels at which you can see that. I think there is a strategic one, considering that if you want to meet the CO2 emissions reductions objectives, you're going to need all low carbon technology, both nuclear and renewables, together with energy efficiency, together with CCUS. The second one is a more technical one, is the fact that nuclear power plants have been traditionally used as baseload power plants, but increasingly we see that they're becoming flexible, and by becoming flexible, that means following the load. So nowadays, some nuclear power plants can vary from 100 to 20% of its rated power in 1 hour. So that's very powerful, flexible asset, not as good as the CCGT, but quite close, comparable with the coal power plant. And by providing this flexibility, that supports the integration of renewables. And the third component, if I may say, is the fact that today's, particularly the existing nuclear fleet, is extremely competitive in Europe, in the USA, and that supports low electricity prices. And by doing so, that means, the policy measures we need to that have cost to reduce CO2 emissions are somewhat more affordable and acceptable for customers. So for all this reason, I think there is a good case to make that nuclear and renewables are complementary and compatible.
Eric, did you want to add anything to the conversation?
Sure, yeah, I would just say, and following up as well on the life cycle analysis, there have been a number of studies out there, and Michelle mentioned some numbers. And I mean, those studies do clearly show that nuclear is very much at the low end of the emissions per megawatt hour of generation produced, looking at all options, including renewables. Of course, this there's always room for improvement in studies like this, but in terms of what has been done, it is pretty clear that nuclear is very much at the low end. And I think, as Michelle also said, I think it's nuclear and renewables are very much compatible. And I think that, going forward to meet climate goals, that we need them to be compatible, because we need all the options available to us to fit together in a system to best manage our emissions.
Michelle, one of the other questions that's come up is about the cost trajectory for development of small modular reactors. How are we looking? Could you just give us a quick update on what the latest thinking is on the cost and availability of SMRs?
Well, I'll start with the availability. Somewhat easier to answer. I think when we look at all the different vendors and developers, in particular in North America, you are talking about new technology with demonstration units by the early 30s. And I think, then that opens the room for large-scale market deployment. In terms of cost, I think it's fair to say that there are still a number of uncertainties, in part because we haven't built the first-of-a-kind units, also because in a number of cases, they represent a shift, a paradigm shift in the way we developed and built nuclear power plants, and that means that typically, regulatory body will have also to adjust the way it's appraised the safety case for nuclear power plants, and because of that means that uncertainties for this technology are of course higher. Putting that aside, the other part of the equation is what are SMRs going to be competing with? Are they going to be competing with very large infrastructures such as CCGT or nuclear power plant, existing nuclear power plant? If that's the case, I think it's going to be hard to be competitive. If you're looking for unless, typically when it comes to competition with gas, you have a very strong price of CO2. When it comes to SMRs, a number of the applications are more targeting areas where the alternative can be expensive diesel generators. So for instance, remote operations, remote mining operations. There is a strong interest for that in Canada. And there, SMRs, considering what the alternatives are, can be competitive. In saying that, I don't want to close the door to the possibility for SMRs, LCOE to be in a range where they will be competitive on the grid. But that part is the one for which we still need to have the demonstration unit built before we can make an educated guess regarding the cost and the competitiveness.
Thank you, Michelle. We have another question along the lines of this thought process. The economic feasibility of nuclear power is hard to justify when its cost is one of the highest in terms of levelized generation among many candidates, and is the market being, is nuclear in a sense being forced in. Let me just take a quick stab at that, is because I think it's important. Not every country has exactly the same cost benefit analysis. And China, which has been a leading country in terms of its support for solar installations, is also leading in the construction of nuclear power plants. And so what I would say is that the cost benefit analysis goes beyond what you might see in any individual country. You have to be, I think, very careful to make sure that you are looking at the availability of resources in different countries, and in a sense taking into consideration the local or national circumstances of each country. But Michelle, maybe you've got a more thorough answer than mine.
Well, I'll try. And I think starting with your point, competitiveness of new nuclear power these days very much depends on which part of the world you're looking at. If you're talking about China, Russia, Korea, they build nuclear power plants on time and on budget and at very competitive cost. China just built nuclear power plants in the 5 years recently. I think if we look at the Middle East region, the Baraka nuclear power plant that is now operational is a formidable example of how new nuclear countries can build on time and at very competitive cost new nuclear power plants. Then there is the issue of, what I call Western OECD, that means essentially Europe and North America, where the last 15 years have been somewhat traumatic during a period of time where we built these large Gen 3 nuclear power plants and we were faced with very significant construction cost overrun. We've actually published a major report on the opportunities to reduce the cost of nuclear power plant. And as I alluded to in my last slide, there is really a window of opportunity to reduce the cost of new nuclear in those countries, building on the lessons that we've very painfully learned from this project. So there's no reason why we can't reduce the cost of nuclear power plant in the coming years, because the reason why the recent projects have faced difficulty and cost overruns are very well identified within the sectors and shared with government. And this are to do with issues related to design maturity, with the stability and the predictability of the safety regulation, and also with the way projects were managed. I think there was an issue within the nuclear sector in terms of project management. And we look at new projects, like for instance, Hinkley Point C in UK, we see that Western OECD, again, we are in a much better position these days to address these issues. Having said all of that, there is one last bit that I think needs to come in this discussion, which is financing. Nuclear power plants are essentially very large capex infrastructures. And so any improvement you can do on financing condition for this power plant is going to have a very significant impact on the levelized cost of this plant. A good example, again, is Hinkley Point C. The cost of capital for Hinkley Point C is reported to be around 9%, leading to a strike price, as they call it, around 92 pounds per megawatt hour. If you reduce this cost of capital to 6%, you're already in a 60 pound per megawatt hour region. So that tells you how much affordable financing condition can do for the competitiveness of nuclear power. And on this front, I think when we look at the global financial sectors and central treasury yields these days, we see that governments are in a much better position to do something about it, because the cost of financing for them has been significantly reduced over the last decade. So that's also an area where a lot can be done. So for all these reasons, I think over the next decade, there is really a very large room for reducing the levelized cost of nuclear power, and you shouldn't base your projection for the cost of nuclear power on this worst case first of a kind project in Europe and North America.
Eric, do you have any questions for Michelle? We're about 5 minutes over our time, but the numbers of participants is staying relatively steady, and we could take another
Sure.
5 minutes before we close.
Yeah, so I was interested, Michelle, when you mentioned and I hadn't really thought about it in these terms before, but I mean, SMRs have the promise because they are smaller and you do have the potential to, essentially manufacture them in a facility rather than a much more costly process of, on-site construction. But that potential really depends on having the same design being used in multiple countries, which means all these countries have to essentially agree or at least have some common set of standards for safety and so on. Is there anyone working on that aspect of it, and how do we? That seems to me like it could be a barrier to SMR, or at least a barrier to the full potential of SMR. So how do we go about addressing that issue of getting various governments sort of in alignment?
No, I mean you put it right, and I know we have a bit of a chicken and egg problem here, and indeed SMRs competitiveness will rely quite a bit on having a global market, at least for some of them, and I think the one that are more looking at remote application and so on or facing a different set of issues. I think what that means is that you're gonna need to move, through some demonstration projects that won't only demonstrate the technology but also demonstrate what the supply chain will look like. And then in doing that, you will need to build another book. In some ways, it is not so different from how you do it in the aircraft industry. The difference is that in the aircraft industry, the licensing approach is well, every safety authority requires each other. So there is a sort of unified framework you can work with. So that brings in the next question as to how we can bring more convergence on these licensing frameworks. And this is clearly an issue that at NEA and with our colleagues at IEA has been identified as a key priority. I think I will be having a workshop at NEA, a weekly workshop on this towards this end of the year. So it's very much part of the ongoing discussions. I think we probably hoping to having a sort of a very fully homogeneous approach across countries is probably not a concrete way forward. You probably gonna have to think about more stepwise progress in this field, and probably what you will see is key countries interested in developing these technologies coming together under the lead of some regulatory authorities. And you can see that today with discussion, for instance, ongoing between US Regulatory Commission and its counterpart in Canada. So you can see that this is starting to take place, but this effort is going to have to really accelerate as SMRs come closer to market deployment.
Thank you, Michelle. There's one last question, and Michelle, you can just relax a little bit because I think I'd like to try to answer it, and I can advertise one of our next sessions in the CCE webinar series. The question was, well, China has plans to build a lot of nuclear power plants, but they're also building coal plants, and doesn't that kind of really fit into what Eric was calling the need for all of the above kind of solutions? let me say that India is also building a lot of coal plants. And I think that it's going to be important that we look at a lot of solutions, including direct air capture of carbon dioxide. Both the International Energy Agency and the Energy Information Administration have come out recently with their forecasts out to the year 20, in EIA's case, 2050, and in the case of the IEA's World Energy Outlook, they were looking specifically at 2030. But all of these forecasts are saying that renewables is the fastest growing source of energy, but even still, we will be needing a lot of hydrocarbons and nuclear power as we move out beyond the 2030 period. And if we are going to still have coal-fired power stations, we really do need carbon capture, sequestration, and use technologies. And in the next series, the next up in the series of webinars that we'll be doing, we'll be looking at technologies like direct air capture, carbon recycling, both biologic and chemical. And we will be examining options for storage of CO2, both geologic storage and others. So I want to give a great shout out to Eric Williams, who authored the summary of the CCE reports, and particularly today to Michel Barthélemy from the Nuclear Energy Agency, part of the OECD in Paris, for the great summary of the role that nuclear power can play in a circular carbon economy. I invite all of you out there to participate in the additional webinars that we'll be hosting, and we look forward to your questions. We will try to capture these questions, and if there are some that Michelle could answer offline, we'd be happy to accommodate that. So once again, on behalf of KAPSARC, let me thank everybody for their participation today, and we look forward to hearing more from you, your questions, your comments as we move through the CCE webinar series. Thank you and goodbye.